In this video, we're going to take a look at oxidation numbers, the assignment of those numbers, and the connection to redox reactions. So the oxidation numbers is basically what the charge would be for an atom if it were an ionic compound. To what degree, positive or negative, would the charge be of that atom if it was giving up the electrons? So the way in which we determine these oxidation numbers is if it's bonded to a more electronegative atom, then it would be losing those electrons, and if it's bonded to a less electronegative atom, it'd be getting those electrons, and if there was an actual transfer of those electrons, what charge would that atom have? So how do we assign these numbers? Well, we have 6 rules which allow us to then assign all these oxidation charges for all these different atoms. First rule is when an atom is an ion, it's actually given up its electrons and it has an actual charge. Well, that's going to be its oxidation number, because the way these numbers work is what charge would it have if it was giving up its electrons. But when it's an ion, it did give up its electrons, so that charge, the magnitude and the sign, is going to be the same as its ionic charge. Second rule is for hydrogen. Hydrogen, being caught in the middle of the wimpiest of the nonmetals, therefore will always lose its electron when bonding with a nonmetal. So it'll always have a +1 charge, and then conversely, on the rare occasion it's connected to a metal, well, in that case, being a nonmetal, it's going to get an electron, and it'll be a -1 charge. Next rule is for oxygen, which almost always is going to be a -2 charge, though it does have a couple exceptions. So being the second most electronegative atom, it's going to always get electrons, with the exception of with fluorine. And when it's with fluorine, well, fluorine is the most electronegative, so actually it's going to lose that battle, and it's going to be making a positive charge. Also, in some instances, when you have a peroxide, you have extra oxygens, then it's only a -1 charge, like we see here with H2O2, hydrogen peroxide. So that extra oxygen, the HOOH, is now going to give it only a -1 charge, because each oxygen is going to be bonded to a hydrogen, and then once to each other, where they're going to be sharing those equally. So the next rule applies for elements in their elemental state. When they're in their elemental state, whether they are a diatomic, oxygen, or fluorine, or they are a noble gas and they're just all by themselves, or if they're in a metal lattice, they're always going to have an oxidation number of 0. Anytime they're in uncombined elemental state, their overall charge is a 0, just like we saw those 2 oxygens sharing an electron in our peroxide. And then, just like ionic compounds, overall, any compound is going to be neutral, so some of these oxidation numbers need to add up to 0, because for every electron lost, electrons gained by somebody else, so we need to have an overall charge of 0. And if it's an ion, then we have an overall charge that adds up to the charge of that polyatomic ion. So whether it's NH4 ammonium with a +1 charge, or if it's PO4 with a -3 charge, the charge of the oxidation numbers has to add up to the charge of that polyatomic ion. So let's take a look at an assignment of some of these numbers. So we're going to use nitrogen quite a bit, because nitrogen can do whole lots of different oxidation numbers depending on who it's bonded with. So this first one here, we see KNO3. Well, KNO3 is an ionic compound, so we know that potassium is a +1 charge. And with 1 potassium, we have an overall charge of +1 from the potassium. Now we'll jump over to oxygen. We know oxygen is always going to be a -2 charge, and there are 3 oxygen atoms, so that contributes a -6 overall. And then being a compound, it has to add up to 0. So I have a +1 from my potassium and a -6 from my oxygens. So nitrogen has to contribute a +5 charge, and therefore with only 1 nitrogen, that nitrogen has a +5 charge overall. So the charges on top are what is the charge for each atom individually, and the charge on the bottom, what is the overall charge coming from that particular element. This next one here, we have N2O4, dinitrogen tetraoxide. Again, we'll start with the oxygen, because we know oxygen is always going to be a -2, with the exception of those couple times when it's a peroxide or with fluorine. But in this case, just nitrogen and oxygen, it's going to definitely be that -2 charge. I have 4 oxygens, so it contributes a -8 charge overall. Being a compound having to add up to 0, I must be getting a +8 from my nitrogens. But this time I have 2 nitrogens, so each nitrogen is going to contribute a +4 charge. So the first example we saw nitrogen at +5 charge. In the second example we see nitrogen with a +4 charge. In both cases though, we don't have actual giving up of electrons. Nitrogen's not going to give up 5 or give up 4 electrons, just the way they're being shared and shared unequally, contributing to that oxidation number that nitrogen has. So let's look at another nitrogen-oxygen compound. Here I have N2O, dinitrogen monoxide. And again, we'll start with our oxygen. It's got to be a -2 charge. I have one oxygen contributing to that -2 charge, so I have -2 overall. And then being a compound needs to add up to 0, be neutral overall. So I get a +2 charge from my nitrogens. But now I have two nitrogens contributing to that +2 charge, so this nitrogen's a +1. So now here we see three different cases with nitrogen having a different oxidation number. Now look at one more compound that involves nitrogen, in this case NH2F. And again, we'll start with our fluorine, because anytime fluorine's in a compound, it's always going to get its electron. It is the most electronegative atom, so it's going to get that one electron every single time. So it's going to make a -1 charge. And there's only one fluorine, so it'd be -1 overall. Next up we have the hydrogen. Again, hydrogen here with all nonmetals, so it's always going to make a +1 charge, because it's going to lose whether it's bonded to nitrogen or fluorine. It's going to give up its electron in that battle. I have two hydrogens, so therefore I get a +2 overall. So now I have a +2 from the hydrogens, a -1 from the fluorine. It has to add up to 0, so I'm getting a -1 from nitrogen. And so therefore, with only one of them, I have a -1 charge for my nitrogen. And now we'll take a look at a nitrogen in an ion. So here I have ammonium, NH4+. So I can start with my hydrogen. It's bonded to a nonmetal, so therefore it's going to be a +1 charge. I have 4 hydrogens contributing a +1, so it gives me +4 overall. But now this time, my nitrogen isn't going to balance out that +4 because it has a +1 charge. So actually it only has to add up to a +1, so my nitrogen is going to be a -3. Then with only one nitrogen, its overall charge is going to be a +3. And now look at one that doesn't involve a nitrogen. But here I have lithium oxalate. Lithium oxalate is an ionic compound, so I know that lithium in group 1 is always going to give up one electron. It's going to make a +1 charge. But then I have two lithiums, so that makes a +2 overall from lithium. My carbon and oxygen are bonded together, so my oxygen is going to get those electrons, so it's going to make a -2 charge. With 4 oxygens, that's going to contribute a -8 overall. And so therefore, I have a +2 and a -8. They have to add up to 0, so I must be getting a +6 from my carbon. But I have 2 carbons contributing to that +6, so each carbon is going to be a +3. So how does this relate to redox reactions? So in a redox reaction, the substance that has an oxidation number that increases, therefore is being oxidized because its charge went up. In order to be oxidized, you must lose electrons. Lose electrons, oxidation. Conversely, one that has a oxidation number decrease is therefore the one that is reduced because charge went down. And again, in order to have your charge be decreased, you must be getting electrons. Gain electrons, reduced. And that doesn't mean it has to be from 0 up to positive to be oxidized. It could go from a +1 to a +2. You're becoming more positive, so you are oxidized. Same thing works for the reduction. A -2 down to a -4 would be a reduction. It doesn't have to be 0 to a negative number, or even a positive to a negative number. Anytime your charge is decreased, you are reduced. Anytime your charge is increased, you are oxidized. So we see that in this reaction here, we have silver nitrate reacting with copper to make copper 2 nitrate and silver. Up top, we see all the charges that are assigned to each of those. And we see our silver is going from a +1 to a 0. So since its charge went down, it was reduced. And then copper went from a 0 to a +2, so it was oxidized. Now since AgNO3, our silver nitrate, allowed that copper to be oxidized, it is our oxidizing agent. And then the copper that allowed our silver to be reduced is our reducing agent.